Okay, continuing on with section 5.6, let's look at another example. The percentage of large or medium-sized companies paying 100% of their employees' healthcare premiums decreased approximately linearly from 33% in 1999 to 17% in 2004. Determine an equation that models the situation. So if we're going to determine the equation, the only type we know how to do at the moment is linear, so we're going to be looking for something of the form y equals mx plus b. So we need to figure out the values of m and b, and we also need to maybe pick different variables instead of x and y that might fit the model a little bit better. So I see two things they're talking about. One is the year and the other is a percentage. And typically when we have a year, that's going to be our input variable, and I think that makes sense here as well. So I'm going to think of the ordered pairs as in is t and out is a percentage. And so if I rewrote this using those variables, then the output variable would be p and the input variable would be t, but we'd still be looking for m and b. So let's look at the information they gave us. They said it was, let's see, 33% in 1999. So I could use 1999 as t, but we typically don't do that. We pick some starting year. So what I'm going to do is say let t equal the number of years since. So we've seen this a lot of times that they would use this sort of wording. And they didn't tell us what year t started in, so we can pick it. And the smart pick would be the first year they mentioned, which in this case was 1999. And the reason that's a smart pick is if you know 1999, which would be a t of 0, then you're going to know your y-intercept. So if we take this information right here that it was 33% in 1999, go ahead and pull that in. That's an ordered pair. In 1999 it was 0 years and the percent was 33. So we get the ordered pair 0, 33. Because this is a 0, we know that this right here is b. And then we still need to figure out the slope, but that's a good start. And then our other ordered pair is in 2004 it was 17%. So 2004 minus 1999 gives us a 5, and that would be the value of t for that ordered pair. So I have another ordered pair which would be 5 for the year and 17 for the percent. So because this one's a 0, I know b, and then I could use these two to get the slope. So for the slope, I would do change in the output divided by change in the input. So the percentage is 17 minus 33, and then the change in time is 5 minus 0. So in the numerator, let's see, 17 minus 33 I believe is negative 16, and for the denominator we have 5. So this would be the slope. So the equation would be p equals negative 16 fifths times t plus the y-intercept, which is the y value that goes with the 0, and so that would be plus 33. And I would make a quick comment that the negative for the slope does make sense because they said that the percentage of companies that were offering this is decreasing, and so when you have a negative slope, your output should be decreasing values. Alright, we went ahead and found this one by hand, and I did that because they had the 0.33, so b was easy to find, and a lot of times that's where the hard work comes in. But I want to go ahead and show you this on the calculator too, just to confirm that we have the right answer. So I'm going to go into Stat and Edit, and I have some data there, so I'll clear that out. And I'm going to enter my two input values, which is the 0 from here and the 5 from there. I'll put those in L1, and then the output values were 33 went with the 0 and 17 went with the 5. Once those are in there, I can do the linear regression process. Stat, calc, linear regression. Data is in L1, comma, L2, and I get a slope of negative 3.2 and a y-intercept y value of 33. So we can see the 33 matches up for the b, and the negative 3.2 matches as well, because if you take negative 16 over 5, you get that same negative 3.2. So we did it by hand, and that wasn't really that much work for us to do it by hand because In this case we had a given y-intercept and that gave us b, but we could have also done it through linear regression, though it does give a decimal that way, which is probably fine on a problem like this as well. In fact, since there's no rounding in that, I'm going to go ahead and change this to that decimal version and make it p equals negative 3.2t plus 33, and that'll make it a little easier to enter things in as we move forward. Typically going to a decimal is a bad idea unless it's requested because it brings in error, but in this case you'll get the same answers out of either form of the equation. Just pay attention on MyMathLab to whether they ask for the fraction or the decimals to make sure you get credit there. Alright, so now we have the equation, and I'll go ahead and box this one as the one we're going to use. Let's go ahead and answer some follow-up questions with that. So estimate the percentage of large or medium-sized companies that paid 100% of their employees' health care premiums in 2006. So this is what they're giving us. They're giving us a value of t. So t would be 2006 minus 1999. So t is equal to 7. And they're asking us what is the percentage of companies. So we're going to plug the t they gave right here into the equation, and that should provide the value of p. So p would be negative 3.2 times the input value of 7 plus 33. And then let's go ahead and enter that into the calculator and see what we get. So negative 3.2 times 7 plus 33, and we get 10.6. So that's the numerical part. I'd still want to give the answer, and the answer would be a percentage. So I would say 10.6% of companies. You could do the full sentence if you want. This is enough, I think. 10.6% of companies, and the further part would be 10.6% of really medium-sized companies paid 100% of their employees' health care benefits. Alright, let's go ahead and move on to part C. Estimate when 23% of the companies paid 100% of their employees' health care premiums. So they're giving us this information. That's a percentage, so P is equal to 23. And they're saying estimate when, so when would be a value of t, so they're telling us p is 23 and they're asking us to find t. So I'm just going to take that equation that we found already and I'm going to plug this in for the value of p and then try and solve for t. So let's see. For p we put the 23, that's equal to negative 3.2 times t plus 33. And now we're going to just do the algebra to solve for t. So I would subtract 33 from both sides to try and get the term with the t by itself. That cancels these out. So then I have, let me bring this over here, negative 10 is equal to negative 3.2t. And then to get t completely by itself, I would need to divide both sides by negative 3.2. Those cancel out. And it's probably going to be a messy answer. Let's see what we get on the calculator. So t would be 10, well, negative 10 over negative 3.2. You could leave the negatives off if you want, because the negative on the top and the bottom would cancel anyways, but leave them off, enter them in either way. And I get 3.125. So t is equal to 3.125. It doesn't give us rounding directions on this, but most of these problems that have a question about when, they're talking about what year, and so I would say that this is approximately equal to 3 years later, and that's added on to the starting year we picked of 1999. So I would take 1999 plus 3, that gives 2002. So I would estimate that in the year 2002, 23% from right here of the companies paid 100%. And this is getting more and more to be a rare thing that a company would pay 100% of your health care. So even if you're lucky enough to have a company that's paying your insurance, a lot of times you're going to pay a certain percentage of it. So that has been dropping over time, how many companies cover that completely, and we would estimate it was in 2002 that got down to 23% of such companies. Alright, let's go ahead and look at another example on page 19. it takes a person 5 minutes to eat all 12 ounces of ice cream in a cup. Let f of t be the number of ounces of ice cream that are remaining in the cup t minutes after the person began eating the ice cream, and find a linear function of f. So I always think it's interesting that we're trying to apply math to ice cream. Maybe ruins the experience of eating ice cream for us, but we're going to go ahead and try it anyways. So on the last problem we did, we kind of decided what our input and output would be and what variables were going to be and what t represented, all those sorts of things. By giving us this line right here, let f of t be the number of ounces of ice cream that are remaining, they're actually kind of setting up the variables, and they're saying that's t minutes after the person began eating the ice cream. They're basically telling us our ordered pairs are going to be t, which is the time, and maybe you could say n, which would be the number of ounces. I'll eventually replace that by f of t. But I know t has to be the input because when they use function notation, they show the input variable inside parentheses. So our output is f of t. For now, I'll just use the letter n, and then I'll replace it as we move forward. So let's look at the data they gave us. They said a person has, let's see, it takes a person 5 minutes to eat all 12 ounces of ice cream. This is a little tricky. The 5 would be the number of minutes that have gone by since they started, and it's very tempting to put a 12 there to say they've eaten 12 ounces. But f of t is not the amount that they've eaten, it's the amount that is remaining. So if they started off, notice it says all 12 ounces, which means they're done at that point. So really I would read that as after 5 minutes they've finished the ice cream, and that means the amount remaining is 0 ounces. And so we need another ordered pair to get our equation, and that would be the starting point. Right when they got the cup of ice cream, so no time had gone by yet, all 12 ounces were still there. So really from that one line we get both ordered pairs. It took 12 ounces, or 5 minutes to eat all 12 ounces, so after 5 minutes none was left. And then we know it started with 12, so at times 0 there were 12 ounces. And because this is a 0 right here, that means this is b right there. So we've got one of our variables, we still need the slope. So the slope would be the change in the output, which is the ounces of ice cream, divided by the change in time. And so what happened with the ice cream? 12 ounces minus 0 would be change in output over 0 minus 5. And on top I get 12. On the bottom I get negative 5, which you could say is negative 12 fifths. Or if you divide that out, we'll go ahead and go with the decimal again because it's exact, you'd get negative 2.4. And the negative isn't surprising because the amount of ice cream that's in that cup is decreasing as time goes by and we eat more and more of it. So we have the b and we have the m, so we have our equation. I'll write it 3 ways. First, y equals mx plus b would be y equals negative 2.4 times x plus a b, which is 12. But that's the standard x and y. We're using n and t, so really it should be n equals negative 2.4 times t plus 12. And then finally, after we make that transition, we'll do one more because they asked us to write it in function notation. So all we have to do to accomplish that is just replace the n by f of t. So I would just write one final line, f of t equals negative 2.4 times t plus 12. And that would be my function for how much ice cream is in the cup t minutes after they started eating. And then a couple follow-up questions. What are the domain and range of the model? So the domain is the set of inputs that are possible. So let's go ahead and think about that. For our domain, that's the input variable, which is t. And typically we think about what is t trapped in between, what are the limits of that. And I think we actually have that right here. You start eating the ice cream at no time elapsed, and you're done with it when 5 minutes are passed. So I would say that this function is going to work for how much ice cream is in the cup as long as we're in between the starting point of eating the ice cream and the ending point of eating the ice cream, which again, according to the problem, was only 5 minutes. And then for the range, you would think about the output variable, which in this case would be n or f of t. I'll go ahead and put the n. Though since n is actually a variable we introduced, I think we'll want to get rid of that and replace it by f of t eventually. But what's the smallest amount of ounces of ice cream that was ever in the cup? 0 when we were done. And what's the largest amount of ice cream that was ever in the cup? There was 12 ounces there when we start. So n is somewhere in between 0 and 12. And again, they asked us to use the output in function notation, so I would just rewrite it and say f of t is somewhere in between 0 and 12. Whoops. F of t with those parentheses. And then the last comment on that is that sometimes people are surprised here because I put from 0 to 5. They want to put from 12 to 0 because they're thinking the ice cream cup was full and then it went down to empty. But when you talk about domain and range and you give an interval of numbers that are possible, you always go from small to large. So the least amount of ice cream that was ever in the cup, no ice cream. The most amount was when we started eating, there was 12 ounces. So the number of ounces is always somewhere in between that 0 to 12 range, and then replacing that in function notation. So there's our domain, and here's our range. And now we've ruined ice cream by making it overly mathematical.